Okay, now we're going to take a look at a theorem for cosine. All right, so the theorem, I have it written over here, but I'm going to rewrite it. Okay, so here's the theorem. I know it has x, but I like u's when you're talking about something in general. All right, so the theorem goes like this for cosine. The limit as u approaches 0, all right, of 1 minus the cosine of u divided by u equals 0. All right, so that's the theorem, where u can be any kind of nested function, like a composite function. Like in our example number 6, it says 3x. So what we're going to do is we're going to take a look at this one, and I'm going to notice that it's nice. It says 1 minus cosine 3x over 6x, and that kind of is the problem, is that it says 6x, and what I really want is a 3x. So what I'm going to do is I'm going to rewrite this, and I'm going to make use of the fact that there is actually a 3 there, but it's just being multiplied by a 2. So let's take a look at that. I'm going to get 2 times 3x, okay? 2 times 3x, and I get my 6x if you work backward, right? So now that I've done that, all right, I put a ring around this because that fits the theorem, all right? And so, since it fits the theorem says that this right here goes to 0. And so, if I have the limit as x approaches 0 of 0 divided by 2, which is just 0 to begin with, right? I get 0, because the limit of a constant is the constant itself. All right? Something important to keep in mind, and I know I've mentioned it in another video. The limit of a constant is the constant itself. Okay, so let's take a look at another problem, and this one right here, you're going to appreciate why your pre-cal teacher was stressing so much knowing those identities, because identities come into play here. So what I'm going to do is I'm going to take a look at this function, or this limit rather, and I'm going to say, okay, the limit as x approaches 0. Now, I notice that it's got a cosine and a cosine there. I notice it's got a 3x and a 3x there. All right, I think I'm going to approach this by factoring stuff out. All right, and that's actually the best approach. So what I'm going to do is I'm going to factor out a cosine from the top, and it's going to leave me with 1 minus the cosine of 3x. Okay, that's really nice. Okay, looks just like that. And then in the denominator, I noticed that they had in common a 3x. And so then that's going to leave me with sine squared of x plus the cosine squared of x. Now, we're looking at it, I'm looking at it, and I see here something really nice. I see sine squared plus cosine squared, and if you know anything about the Pythagorean identities from pre-cal, it's that sine squared plus cosine squared is 1. So that's going to be 1 right there. The next thing that I notice is that I have this right here, and I'm going to put a ring around it. 1 minus cosine of 3x over 3x, which follows my limit theorem right there. And that says that this all goes to 0. So I'm left with something that looks like this. The limit as x approaches 0 of the cosine of x times 0. But that's just the limit as x approaches 0 of 0, because 0 times anything is 0. And then the limit of the constant is the constant itself. So my final answer here for this one, while it looked like a really big monstrous problem, the answer is just 0. So creative application of the theorems, as well as your use of the trigonometric identities, will get you through something like this. Okay, but not terribly difficult. I hope this video was helpful, and as always, like and subscribe.